All right, before we deep dive into time series, let's do a very quick recap. A time series forecast is a time-ordered sequence of observations. Here we have our observations, and on this side, we have our time-ordered sequence that's been taken at regular time intervals. In this case, every month, we make an observation. Again, it can't be stressed enough that we are making an assumption that future values can be estimated from past values of the time series. Okay, so the first thing we're going to do is we're going to become familiar with different types of patterns that arise out of collecting data to make our time series forecast. Let me draw out a chart. Because this is a time series, the X represents time. And for this one, we'll say that the y-axis represents, we'll say revenue. And when you start collecting data, and you start plotting it, and you suddenly notice that there's a pattern that looks like this, you know that we have a trend pattern. And trend patterns can either be positive, as in this case, or it could also go down and have a negative trend. For seasonality, we see a different pattern. You start collecting data, and all of a sudden you notice the data looks something like, you see that we have a seasonal pattern or seasonal variation. Like our textbook says, seasonality refers to short-term, fairly regular variations generally related to factors such as the calendar or time of day. Another pattern that you might encounter is that as you're collecting the data and plotting it onto your charts, it looks something like this. And that's what we call cycles. Like our textbook says, cycles are wave-like variations of more than 1 year's duration. Another thing we need to be aware of are variations, and there are two different flavors of variations. Earlier, we talked about the trend pattern, which looks, again, something like this. As you can see, there are all these bumps. When we average these out, we get our trend line. But the variations from here to here, from here to here, these are what we call random variations. And they are residual variations that remain after all other behaviors have been accounted for. However, as in this case, we have this bump, which does not match the random variation. This is what we would call an irregular variation. And we would want to find out what is causing this. They typically do not reflect a typical behavior, and so we really need to figure out what is causing such an irregular variation. All right, the first forecasting method we're going to look at is the simplest, and it's called the naive forecast. As a rule, you take the single previous value of a time series as the basis for the forecasting. So in this case, we have 4 time periods, and we have listed the number of units sold per each time period. So here we have the historical data, and we need to find out, using the naive approach, what is the forecast for time period 4. In this case, taking this rule, we forecast time period 4 to have 6 units sold, because we're taking the previous value and we're saying it's going to be similar to our forecast. So when we're applying the naive forecast to a stable time series, it is pretty much like the example we just did. In this example, last week we sold 50 tires, so therefore we can expect to sell 50 tires this week. When we apply a naive forecast to signal variations, it's pretty much like the last example, but with a tiny little twist. Here we say that we sold 400 chocolate roses, so let's say 400 roses, between February 1st, 2016 to February 14, 2016. Therefore, according to the naive forecast, we can expect to sell 400 roses during February 1st, 2017 and February 14, 2017. When applying a naive forecast to data with a trend, it's pretty much the same with one additional step. You need to figure out the change in demand. So in this case, we want to forecast how many lattes we can expect to sell today. And we know that yesterday, marked here by -1, we sold 50 lattes. And the day before yesterday, marked here by -2, we sold 45 lattes. This shows us that there's been an increase of 5. So when we add another 5 to the 50, we get 55 lattes. Naive forecasts may seem overly simplistic, and they are, but there are several advantages for using such a forecast. First of all, they're simple to use and easy to understand. There's pretty much no costs associated with making a naive forecast, and you literally do not need to know any data analysis to create a naive forecast. However, and as you've noticed, this forecasting method isn't very accurate. So in the following videos, let's take a look at a few more time series forecasting methods that will improve on this accuracy.